Mic testing, mic testing. Let me check if it works. Alright, we live again. Let me go here real quick. Okay. Let me go to announcements and just copy the link here. We live. Okay, so guys, what are we going to be doing this live? Let me just share. Okay, let me just mute this real quick. Okay, so let's do some more Python questions. Last live stream we went through, I was learning args. I might start quarks today. I'm definitely starting quarks today, but I might just revise some recursion as well. And guys, I'm not warmed up. You guys can yeah, I can't talk properly right now. Okay, so let's go up to ChatGPT Sensei and say we live. Here, what's up, C Show? How you doing? Once again, good evening. What's up, Gen V? Now, make sure to sleep. Alright, so welcome warriors. The terminal has ignited. The keyboard is hotter than the sun. Vivek has entered the digital colosseum and he's here to tear through logic like a monster. Today we continue the recursive logic puzzle, a deadly test of brain power, recursion and willpower. No cheats, no crutches, just cold merciless code. If you are here to learn, sit down and take notes. If you are here to test your limits, brace yourself. If you are here to watch a legend be forged, you're in the right stream. Now Vivek, last time you were building digit sum lock, okay? A recursive puzzle that adds up the digits of a number and checks if the total is exact. And guys, ignore the background noises. Someone is like lawn mowing here. Okay, ready to continue? Type your function, sum digits, then build the full lock system. The world is watching. Let's go. Okay, let's see here. Ready, Sensei. Ready, set. Guys, ignore me for a bit. I'm not warmed up. Okay, and let me open the chats here too, so like I can see the chats properly. Alright, so that's what I want to hear, Vivek. The stage is yours. The code is hungry. Time to unleash your first lock system. Step-by-step goal recap. We're building the digit sum lock, part of your recursive lock puzzle game. Here's what you need to code right now. Ask the user to enter the vault code or the vault code. Pass the number into your recursive function, sum digits. If the result equals to 10, print vault unlocked. If not, say incorrect, try again, and ask again until it stays right. You already have this logic. Define sum. Okay, so we defined a function called sum digits and added a parameter n. If n is less than 10, return n, else return n modulus 10 plus sum digits. We invoke this function and floor division 10. Okay, so basically what does n modulus 10 do? N modulus 10 gets the last digit of our number, and the n floor division 10, it cuts the last digit of our number. Now build this whole flow. Instruction in plain English. While true, ask for input, convert input to an integer, okay? Pass it to your recursive function. If 10 if result equals to 10, print unlocked and break the loop. Else print try again. I always forget to play my live. Okay, now write that code, Vivek. Type it out live. No copying from me. Just fire, go. Okay, let me just get this here real quick. And open my live here. Alright, so let's see. And guys, I'm not warmed up yet, so I might not be that fluid. Okay, ask for a input. So let me go with the ask. I'll make a variable ask and set it to be input. Enter a number. Okay, finally the guy that was lawn mowing, he left. I was like, oh god. Okay, convert input to an integer. Okay, so I typecast this to an integer, and then pass it to your recursive function. So I gotta pass it to my recursive function. If result equals to 10, print unlocked and break the loop, else print try again. Alright, so let me drink some water first. I need some hydration for my brain to work. So let's see what should I do first? Since we're using recursion, let me add a base case. So if my ask equals to 0, actually I need to define ask in. Okay, so this is the question. Ask for input, convert input to an integer, pass it to your recursion function. Okay, let me ask for a small hint, guys. I'm not warmed up. Sensei, can I get a hint? Because I'm kind of confused. Do I need like define a function? Okay, let's read. You want a hint? Fine, I'll give you just enough to light the flame. The rest is on you. Hint. You need a loop that keeps asking the user until the condition is met. That means you. Okay, while true, ask input, convert into integer, use sum. Okay, if digit equals this, else keep looping. Okay, important. Remember to convert code from string to integer or recursion will fail and I will unleash shame. Okay, now go fix your destiny. No more hints. You have the pieces. Build the damn lock. Okay, I thought that we could only use recursion using functions. Never mind. Okay, so I typecasted my input to an integer and then a new statement. So ask for input, convert it to integer, use sum. Okay, pass it to your recursive function. So if my ask equals to 10, I'll print print unlocked. Okay, so I'll print unlocked and I'll add this to a while loop. So while true, and then I'm gonna indent this. To mass indent it, you just highlight everything and hit tab. That mass indents it. So if my ask equals to 10, print unlocked, else print try again with an exclamation mark and unlock. Then I break the function. Okay, this should work, but I don't see a recursion here, guys. Okay, let's see if I would run the command 11. Oh, okay, hold up. Let me try again then. Oh, my input should most likely go here. Okay, there you go. I didn't want to debug it. Here, 11. There you go. Try again. Enter a number. What if I go with 10? Unlocked. Okay, perfect. This didn't seem like recursion. Let me ask again here. Go here. Sensei, I thought that we can only use recursion for. I thought that we can only use recursion for functions, and I feel like I didn't use recursion here. Exclamations. Okay, so we set the code. Ding ding ding, you're right, student. You didn't use recursion, you used a loop, you stubborn little warrior. But hey, you're awake, you're thinking, and I'm proud of that. Now let me teach you why recursion is needed here. Stay sharp or I'll make you write it 30 times. Okay. Why your code is wrong but close. You used a while true loop with a break condition. That's perfectly fine in many cases, but this challenge is a test of your recursion skills. That means you must call a function from inside itself until the correct input is given, okay? The core idea of recursion. Here's the pattern you must follow. Okay, I knew I gotta define a function. Okay, so define ask user. Ask equals to integer input entry number. If ask equals to 10, that's the base case. Else print the. Okay, ask user. This is the recursive call. See that last line? That's recursion. Okay. You're telling the function call yourself again until it enters 10. Oh, I see. Alright, so when this is basically me invoking my function. So I invoke my ask function, so it's gonna reprint my ask integer. Okay, I didn't know that was recursion. I thought that recursion was like only when so I thought recursion was something like I gotta like remove the index 0 of a number or a string and then add it to like the index again. I thought recursion was something like that, like cutting something and then adding something else, if that made any sense. Okay, let's see your mission. Rewrite your code using this format. No while, no break, only recursion. If you mess it up again, I'm gonna make you type. Recursion means calling a function from itself 30 times in blood red font. Go now, code. Okay, as you say, sensei. Alright, so I want to look at the loop, so I actually know what to do. So I'm going to first define a function. I'll go with ask user. I'll add a parameter called, I don't know, x. Okay, and then I'm gonna add a while loop. So while true, I'm gonna add a input, not pretty sure it should be x. So x equals to input. Enter a number. Okay, if my x equals to 10, and guys, this is the base case. So if my base case, my parameter x here, if it's equal to 10, then I will print unlocked. Else if my base case is not met, now it's my recursive case. So for my recursive case, let me go with something like print. Okay, honestly this is not my recursive case yet, so it's just else print try again. Okay, and this is the recursion now. So once it's else, it says try again. So I want to invoke my function again. So to invoke my function, if this was a regular while loop, I didn't have to invoke my function because it's going to keep on looping through this. I gotta add a break here. Okay, but since this is a function, I gotta go here and invoke my function. My function is ask user. Hey, did I have to return anything? Okay, wait, let me go here and invoke my function again. Ask user x. This doesn't make sense. Okay, let's see. Actually, let me check real quick. Don't use while. Oh, don't use a while loop. Okay, let me try without the while loop. I'm pretty sure I need to add like a return, right? So like return. There's nothing to return. Let me like check the code for reference real quick. Oh, if x equals to 10, which is less, then you will return. Oh, then I gotta like return here. Let me just do this. Return unlocked. Does it make sense? Return the if condition. Oh, okay. Let me go here and return. Try again. Then do I gotta invoke it here? Like here. Okay, wait, let me just check this reference real quick. And when you're calling the ask user in a parenthesis. Oh wait, don't you need to like share like, oh, I need this. Okay, let me just check this real quick. Okay, so ask user, okay, and then if ask equals print unlock. This is the recursive call. Let me copy this real quick and check like where did I mess up. Okay. Oh, I don't need a parameter here. Okay, I'll have to ask why did I need a parameter there. Okay, and let me change this to ask. Guys, I'm just like copying this for now because I'm still warming up. Let me change this to ask and print unlocked. Delete this. Oh, actually, no, man. Indent print. Try again. Okay, now once I'm done invoking, I'm gonna ask why did I have to add a parameter up here. Let me just open this real quick. Okay. So I'm gonna invoke my ask user function. Now if I were to run the command, enter. Okay, and why did I have to like add a print statement here? Well, because I don't have a return here, so it's going to return none. And if I don't want to like see that return none, that's the reason. Because if you have a print statement inside of your function, I don't think that you need to like, I'm pretty sure you don't need to like print your function that you invoked. So let me enter a number. Let's go with 11. Turn. Okay, oh, I forgot I had a break. Let me add a break. Oh wait, there's no break here. Okay, let me just copy this real quick. Let me go here. Use this to visualize your code, understand the flow of the code. Alright, let me try to understand this code real quick. Okay, let me paste this and say, Sensei, I feel like I messed up. Can you explain the code to me? Question mark. Yes, you messed up, but good, because now you're asking questions like a true warrior who wants to master this craft. Now sit up straight and listen with your soul. Wait, this is recursion, but you got one small problem that could break your entire mission. I'm going to teach you what you did right, then rip apart what you did wrong. Ready? Okay, what you did right. You're using recursion by making the function ask_user call itself when the condition isn't met, okay? That's exactly what recursion is. A function calling itself over and over until a condition called a base case is met. Great job spotting the difference between a while loop and a recursive loop. Oh yeah, recursion is a loop. I didn't need a loop. Okay. Your code explained line by line. Define, okay, so define this function. Ask equals input, enter a number. In which standard you are, where are you from? Okay, I'm currently in the United States. And I'm still like a beginner. Okay, you ask the user for input. Good, but notice ask is a string, not an integer. Oh, that's going to matter later. Okay, nice. Hey, I've almost got Maze, the program language I'm making, done. Good luck, C show. Like, congratulations too, the command prompt for it. Okay, that's perfect. Let me also lock in. Okay, so if ask equals 10, print unlock. Mistake 1. You're comparing a string ask to an integer 10. In Python, 10 is not the same as 10. Okay, yeah, a string 10 is not the same as an integer 10. This condition will never be true even if the user types 10. Do you know Tamil? Guys, I'm a little stupid at languages. I mean, I know a little Hindi. I mean, actually I'm pretty fluent in Hindi and like, I know English. Those are like the only two languages I know. I should probably learn more languages. I was learning a little Spanish, but I'm bad at it. The only thing I know is like how to greet people. Okay, so if integer ask equals to 10, okay, that's my fix, okay? else print try again, ask user. This part is correct in terms of logic, but you're calling the function again if the answer is wrong. That's recursion in action. Ask underscore user, okay? This kicks off the first call to the function. Well done, okay? The real danger is stack overflow. Unlike a loop, recursion adds a new function called the stack every time. It's called, unlike a loop, recursion adds a new function to the stack every time. It's called, oh, okay. If someone enters the wrong number 10,000 times, boom, stack overflow. Oh yeah. That's why while loops are safer for repetitive tasks, but recursion is good when you know there will be a natural stop. The structure naturally fits recursion, like trees, graphs, and backtracking. Okay, final fixed code. Sorry to ask. Don't apologize. You guys can ask me any questions. I like it's pretty fun to answer questions. In recursion, there is a base case and a recursive call. These is the main thing. Okay. In the base case, you may say the loop breaks. Oh, okay. Yeah, okay, so like if my base case is 0, recursion is basically going to cut itself down until it doesn't reach 0. Once it reaches 0 and it hits the base case, the recursion stops. Okay, that makes sense. TLDR, you used recursion correctly. You compared a string to an integer. Wrong. Oh, okay. Convert input to integer first. Recursion works but is dangerous. If it can go forever, Python will crash eventually. Okay? For something like this, while loop is better too. Still, great use of recursion and structure. You're getting it. Now say it with me and write it 10 times. Recursion is a function that calls itself until a base case is met. Guys, my throat already hurts. I've been streaming like for I think 6 days, like for 6 hours, 4 hours, like 2 hours. My throat is killing me. So I'll just skip that saying 10 times. After that, tell me when you're done. I'll throw you into the next challenge like a good sensei should. Yeah, right. What are you planning to do now? Okay, so I'm just basically planning to I started like a 100 days series where I like learn how to use Python. It was actually going to be where I learn how to use Python while teaching you guys with like a weekly progress, because like when I first started, I was learning about print statements, variables, typecasting, user input. I thought those were pretty easy. I got hampered real bad because things took like a drastic turn. It became real hard, and since these things were like actually pretty hard for me to learn, I would get distracted. So I was like, if I stream, then I'm definitely not getting distracted. I got some pressure on. And like, I'm definitely gonna make that game like on day 100. I need to like check how many days are left for that. And I thought I'm gonna make like a 3D game. I'm gonna first make a text-based game because I still didn't learn about Pygames. Hey Viv, is it okay if I add you on Discord? Yeah, you guys can add me on Discord. Like until like I have max friends. Okay, nice idea. Thank you. Okay. Before I say I'm ready for the next question, I do want to try fixing this code real quick. Okay. Let me just check the reference. Okay, what if I just copy this code? Is this the same as this? So integer, okay. The code is honestly the same. Let me delete this. Run the command. What if we go with 10? It says unlocked. Is it some? Oh my gosh, guys! I'm so stupid. There's no way I forgot to typecast this. Okay. Yeah, I should like start paying more attention. My attention is like awful. Okay, so now if I type 11, try again. If I type 10, unlock. Perfect. Although I don't take credit for this question because I didn't do anything. Of course the same. Let me just copy this. Yes, that's what I'm talking about, Vivek. You took the flawed code and punched it straight into perfection. Let's break it down so it's carved into your brain like a scared symbol of power. Final code, define, ask user, ask equals to input, enter a number that's typecasted to an integer. If number equals to 10, print unlocked, else print try again. And instead, this is basically the recursive function, so it re-invokes the function if the else case is met, okay? and then I invoke the function. The reason I didn't print my function while invoking it because there is no return statements here. Okay, what this code does, ask user, this is a recursive function, a function that calls itself. It asks the user for a number integer input. You fix the bug by converting the input to an integer. Since input gives a string by default, the number is 10. It prints unlock the victory condition, okay? If it's not 10, it prints try again and then repeats the process by calling itself again. Bonus insight from Sensei Sarah. I kept my sensei's name Sarah, I like that name. This is a recursive solution, and why it works, there's only one danger. If the user enters wrong numbers too many times, you'll get a recursion error. Yeah, because it can't go more than 1,000. Because Python has a recursion limit of 1,000 by default, every wrong attempt stacks in memory. How to avoid this later, not now? How to avoid this later, not now, later. Replace recursion with loop when it's time to go pro. For now, you did exactly what I asked. You crushed the bug. Sensei is proud. You get a strong nod of approval, a firm pat on the back. And the master is not the one who never fails. The master is the one who never quits. Guys, that's a pretty good quote. Now, get ready for the next question. We're just getting started. Ready? Use conditional operator instead of else. It upskills to write cleaner code. Conditional operator. Let me just ask real quick. What is, before, let me just say, ready, Sensei? Before the next question, can you tell me what a conditional operator is? Question mark. Yeah, guys, ignore my typos. I can't spell while I'm talking and spelling at the same time. Go here. I learned about conditional expressions. I don't know if that's the same thing. Alright, good, you're back with fire. Let's keep this blaze burning. But first, listen up, maggot. Yeah, listen up, maggot. You asked a good question, so here's your answer. Read it 30 times if you dare forget it again. What is a conditional operator? Also called ternary operator. Okay, yeah, so ternary condition is like, it's like conditional conditional expressions. A conditional operator in Python is one line shortcode. Oh, so it's the same as conditional expression. It's like, if some condition is met, do something else, do something else. That's how we write. So if something, do something else, do something. Okay, yeah, I honestly prefer doing that as well. Okay, age equals to 18. Status, if age is greater than or equal to 18, print adult, else print minor, print status. Oh, okay. So basically, it's like saying, hey Python, if this condition is true, give me this, otherwise give me that, all in one line. Don't confuse this with regular if or else block. This is just a shortcut, not a replacement. Repeat this in your brain 30 times if you're still unsure. If condition, do something else, do something else. Say it, write it, breathe it, live it. Oh, live it. Okay. Okay, guys, live. Okay, ready for your next broken code question on conditional expressions. If you're not too bad, we're doing it anyway. Let's begin. Sensei, I prefer writing your caps. Sensei, never mind. I remember what it is. I thought that conditional. Let me just change this. I thought conditional operators was something else. Honestly, yeah, that was kind of stupid of me. Okay, never mind it. Never mind. There you go. Okay. Good, don't doubt yourself unnecessarily, Vivek. You've come here too far. Get shaky over something you already know. Since you're warmed up again, it's time for Broken Code Challenge 2 on conditional expressions. Okay, I guess we're doing a conditional expression. Hey, let me go here and paste this. Okay, check. Okay, so we define a function number. If my number is greater than 0, print positive. else print negative or 0. Print result. Okay, we didn't add our number here. Let me go with 2. And I don't have to print this because I don't have a return function here. I'll show that in a bit. So it says positive, but what if I printed this? Print, it's gonna give me a none as well. So if I run the command, it's gonna give me none unless I return my result. Unless I return my result. There you go, but I'll leave it as print. Okay, although I do wanna now go back to recursion. Oops, not that. There you go. Okay, Sensei, can we return to recursion questions? You dare ask to return to recursion before mastering conditional expressions? Oh, there you go, guys. I thought conditional operators were different from conditional expressions. Okay, they're the same thing, but you've already proven you remember them, and your last answer was correct. You earned that ship. Fine, you want recursion again? Then brace yourself. We're picking up where we left off, and this time is going deeper. No running, no mercy. Mental preparation. The difference between a master and a novice is that a master has failed more times than a novice has tried. It's definitely not from the assassination classroom, the anime. Okay, let's see if you still remember the recursive mindset. Here comes your next recursion fix. This is broken code. You fix it, not try, not guess, fix it. Broken code 1, fix it or cry. So we define a function, okay, we define sum to a number and added a parameter of n. If my n equals to 1, return 1. Else, there's no else, but I like calling this as else. Let me know if this is called something else. Else return n plus sum. Okay, I see. Okay, something is wrong here. Your mission: spot the error, fix the code, explain what you changed. Go or I'll make you write recursion is my destiny 100 times. Okay, let me get this here. Okay, let me just copy the broken code, paste it here. Okay, I might know. I'm pretty sure I gotta use indexes. So it says 0. Okay, it gives me a recursion error. That means the base case is not met. If n equals to 0, return 0. Okay, honestly that might be the only problem here. Let me change this to 6. This should print 654321, right? Oh wait, that was in the... Okay, let me just ask, what's this code supposed to do? Sensei, before I solve the question, what is this code supposed to do? Question mark. Good question, Vic. You're thinking like a true student of code. Here's what the code's supposed to do. Define count list. If not list, return 0. If is instance, okay. If is instance, I didn't learn about the is instant built-in function, not even the list one, okay. The goal, this function is meant to count how many nested lists exist inside a given list. That includes inner lists, no matter how deep. Okay, it's nested. Example. Okay. How it works: base case, if the list is empty, return 0. Okay. If the first element is a list, count with plus equals to 1. Then recurse into both that list at index 0 and the rest list at index 1. Okay, I understand this part. If it's not a list, just recurse into list 1. But be careful, the current code has a bug. Find it, fix it, or I'll bury you in 100 nested lists. Okay, base case. If the first element is a list, count it with, okay. I honestly still don't understand it. I honestly still don't understand it. Can you explain this question to me real quick. Okay, let's see. Condition question mark true part false part is the syntax for most of the programming. Oh, I see. Okay, listen up, Vivek. I can see you're struggling, but I won't let you slip through the cracks. This is important. You're not just learning to code, you're learning to think like a programmer. Breaking down the function, count underscore nested list step by step, okay? Goal, count how many lists are nested inside a bigger list at any depth, okay? So there's a list, inside the first list there's a second list, inside the second list there's a third list, okay? What are we counting? The elements 2 inside the elements 3 and 4 inside the list of 2 is a list inside the main list, count 1. Inside that list 3 and 4 another list nested deeper, count 1 more. Total nested list 2. I see. The function logic. Define count, okay, list. If not list, return 0. Oh, so is this okay? No, that's just a parameter. I thought that was like a built-in function. Base case, if list is empty, no list to count, return 0. Base case, if list is empty, no nested lists to count, return 0. If is instance, okay, I gotta ask about the is instance method. If instance list at index 0, list. Return 1 plus count nested list, okay, plus count underscore nested list from index 1, okay. I understand this part. If the first element of the list is itself a list, then count it as 1, recursively count nested, okay, let me just copy this real quick. Recursively count nested list inside that first element. Count underscore nested list at index 0 plus recursively count lists in the rest of the list. Count underscore nested list at index 1 until the entire string, okay. Else return count nested list everything from index 1 till the end. If the first element is not a list, just check the rest of the list, okay. Why use recursion? Because nested lists can be because lists can be nested indefinitely. You don't know how deep they go. Recursion lets you explore all levels without writing complex loops. Summary, base case ends the recursion, empty list. Recursive case, check each element if it's a list. Count it and go deeper. This repeats until all elements are nested elements. Okay guys, my bad. This repeats until all elements and nested elements are checked. Now, think about it. Do you see why the function needs to call itself on at index 0 the nested list, and on list at index 1 the rest of the list? Okay. If you don't get it, you'll write recursion means thinking deeply 30 times and then come back. Okay. Are you ready to tackle the bug now? Show me your fight. Okay, let me just ask the question. Sensei ... I never heard / learned about the is instance function. Oh, I didn't want to caps. Never mind. Can you help me understand that question mark? I got the maze command prompt working. Yay, congratulations, C-Show. Okay, listen up, Vivek. If you're guys, I gotta drink some water real quick. There's no way I can read all this without water. Guys, my throat's killing me. Okay, listen up, Vivek. If you're going to master Python, you can't be ignoring important tools like isInstance, okay? I'll teach you this now, and you will remember it like it's your last breath. I see. What is isInstance? IsInstance is a built-in Python function that checks if an object is an instance, specified class or type. isInstance is a built-in Python function that checks if an object is an instance of a specified class or type. Oh, I see. Okay, syntax isInstance object class info. It says class info. Is this related to object-oriented programming, guys? I still didn't tackle that. Object, the value of variables you want to check. Okay. Class info, the data type or class you want to check against. Example list integer string. Okay. What it returns: true if object is one of type slash class info or a subclass. False otherwise. Hey Viv, can I add you on Discord? Yeah, add me on Discord. I'll accept it as soon as possible. Or even like when I want to break, I'll accept it. Okay, examples: print isInstance 5 comma int. True because 5 is an integer. Oh, I see. Oh, print isInstance hello string. True because hello is a string. Print isInstance 1 2 3 list. True because it's a. Oh, I see. Print isInstance 5 string. False because 5 is not a string. Oh, okay. So is it something like the type function? Like I want to check what type my variable or like my string or integer is. If I want to check what type it is, I could print, and then inside the print statement I could use my type function, and inside I could enter my variable name. And if that variable is an integer, it's going to say if it's an integer. If it's a float, it's going to say float, boolean, and string 2. Why is it useful in count underscore nested? We use it to check if this element is a list. If yes, treat it as a nested list and count it. Okay. Because the list inside lists are what we want to detect and count. To sum up, isInstance x list is a question. Okay, your code asks. Okay, hey, is x a list? I see. If yes, you act accordingly. If no, you do something else. Your challenge: write 3 print statements using isInstance. Check if 42 is an integer, Python is a string, 1 2 is a list. Send them to me. You don't want to hear me yell about basics again. And remember this: a warrior's strength is in the tools they wield. isInstance is your new sword. Send the request. Okay, I'll accept it as soon as I go on a break, because I didn't eat anything today as well. Okay, so let's go up here, write 3 print statements using isInstance. So I'm gonna add a print statement using isInstance. So let me print and then use the isInstance function. Is my 42 an integer? Let's see if that's true. And then I'm gonna print and use my isInstance. Is my string Python a string? And then the third one, I'm gonna print and use the isInstance and check, is the list 1 comma 2 a list? Okay, what if I go here? Okay, I gotta check if this is a list. Let me write this again. Okay, so my isInstance is my 1 comma 2 a list. There you go. If I run the command, all 3 are true because 42 is an integer, Python is a string, and 1 comma 2 is in a list. Although I do have one more question. What's the difference between the type function and the isInstance function? Sensei, what's the difference between the type function and the isInstance function? Question mark. Guys, ignore my typos. I cannot type when I'm speaking. Okay, well, isInstance, instead of having to use isInstance, you could use this to make sure a variable is a certain data type before it is used. Example, my num int. Oh, I see. Okay, Finally, a good question that separates the rookies from the code warriors. Listen close, Vivek, because this is one of those details that makes your debugging and designing skills sharp as a katana. Type versus is instance. What's the difference? Aspect, type, and is instance. Purpose. Return. So type returns the exact type of an object. Is instance checks if an object is an instance of a class or a subclass. Usage. Type of my object equals some type. Instance object some type. In inheritance aware, no, type only matches exact types. Yes, recognizes subclasses and parent classes. Oh, I see. Okay, example, class animal. This is object oriented programming, guys. I watched a few videos but I didn't learn it yet. Pass class dog animal pass equals to dog. Okay, so in short, use type if you want to check the exact type. Rarely recommend for polymorphic code. I heard about polymorphosis as well. I don't know what does that mean. I didn't even check any videos on it. I just heard it. Okay. Use is instance when you want to check if an object is of a certain type or inherits from it. Much more flexible and powerful. I know the word inherits is used when talking about object-oriented programming. I again don't know about that. Why this matters for you? If you only use type, you'll miss subclass relationships, which is critical when your code deals with complex data or class. Guys, I forgot how to pronounce this. Hierarchy? I don't know how to pronounce that. Remember this like your life depends on it. Is instance knows the family tree. Type only knows the individual. I see. Ready for the next recursion challenge, or do you want to practice this more with examples? Let me just say, Sensei, I didn't start learning object-oriented programming yet, or anything above it, ... I know almost everything until args. I'm just reviewing. What was I reviewing? Recursion. I'm just reviewing recursion! Exclamation marks. We're doing some water. Alright, oh, you're smart enough to know you haven't learned object-oriented programming yet. A guy made a joke and said learn poop means Python object-oriented programming. Yeah, just wanted to say that. Yeah, good. That means you're not getting ahead of yourself. Respect. So let's not drift into object-oriented fog. Here's the deal. For now, treat is instance simply as a tool to check types without worrying about inheritance or class you haven't seen yet. For your current level, is instance X list means X is a list. Yes or no, simple as that. So with that cleared, let's return to recursion. I'm dropping the next question challenge for you to fix. Broken code recursion number 2, fix this. And guys, this is just warm up. Soon I'm going to go for instruction based questions too, so where ChatGPT Sensei says me what to do and I like just do it. Like I get instruction, not a code. Okay, we defined a function called factorial and we added a parameter n to it. If n equals to 0, return 0. Else return n times factorial n minus 1. Okay, so basically what does this mean? I did the factorial question, so I know if I know what's wrong. For factorials, this needs to be 1 because if n equals to 1, return 1 because we're multiplying, and any number multiplied by 0 is 0. That's why if we change this to 1, any number multiplied by 1 is the number itself. Now about the recursive case. N multiplied by factorial n minus 1 means my 5, for now my n is my 5, it's going to multiply with my n minus 1, so it's going to multiply with 4 because n minus 1 is 4, and then my n is going to be 4 for my second loop. Let me just show you guys, this might sound confusing. Okay, let me go here, paste it. and change first. Let me run the command. It's going to give me 0. If I change that to 1, it's going to give me 120 because my, excuse me, okay, because that's my n is 5 and 5 multiplied by factorial. Okay, so it's 5 multiplied by n minus 1, which is 4. Now my n is going to be 4 in my second part of my loop. So 4 multiplied by factorial n minus 1. So my next n is a 4. So 4 minus 4 multiplied by 3, because 4 minus 1 is 3. So yeah, you guys get the gist of it, right? The reason I know this is because I did this code a lot of times. I need to go with some instruction based codes now. Okay, Sensei, I feel like I understand this. ... Can I get a few recursion based codes now? Question mark. Codes. Recursion based codes now? Question mark. Hell yes, Vivek, that's a clean, sharp fix. Perfect factorial function. You're mastering recursion one brutal step at a time. Sensei is proud. Now let's reinforce our recursion foundation with some base code examples. Here's a 5 simple recursive functions you must know by heart, okay? Here are 5 simple recursive functions you must know by heart. Write them, then run them, and own them like a true warrior. Countdown. Okay, so I defined a function called countdown. I added a parameter n to it. If my... Wait, didn't I ask for instruction-based codes? If my number equals 0, print blast off, okay, else print n minus 1. Okay, let me copy the first code real quick. I wanted to instruction-based, but let me just see if I actually understand this. So if I run this command, it's not going to give me anything, probably because I didn't invoke the function. Okay, let me invoke the function and type 5. Alright, and why am I not printing it again? Well, because I have print statements inside of my function. One more thing, space. Okay, if I run the command, oh, it does give me 5, 4, 3, 2, 1. Wow, what happens if I copy this, delete this, and paste it here? Oh, I see. So okay, so having the print statement above my n minus 1 is going to give me numbers backwards, and having my print statement under my countdown n minus 1 is going to give me numbers forward. I see. Let me control C that. Come here, control V. Guys, I'm losing voice by the second. Okay, let's go here. Sum of n numbers. Let me paste the first question. And drink some water. Alright, yes, Vivek, that's exactly how you do it. You wrote the countdown recursive function perfectly. Breakdown, base case. When n equals 0, print blast off and stop recursion. Recursive case, print the current number, then call countdown n minus 1 to cooldown. Each call reduces n by 1, moving closer to the base case. Recursive case, print the number, then call countdown. Okay, each call reduces n minus 1. Oh, I see. Okay, moving closer to the base case. This is the power of recursion. Simple, clean, and effective. Now, don't get lazy. Pick 2 more. From the list I gave you, write the code, explain them, and send them over. I'll make you count down from 100 with your eyes closed. Okay, I guess I go up and I copy the code. Let's see which one. So, count number of digits. This sounds a little confusing. Might do that. Okay, Fibonacci numbers. Okay, naive, print strings. Guys, I know what Fibonacci numbers is, but I actually kind of forgot. I honestly do know. Let me just check the definition. Chi meaning. Okay, definition. The Fibonacci numbers may be defined by the reoccurrence relationship. N minus 1. I'll just ask Sensei, I guess. Sensei, I know how you can run my code. Check your DMs and see further instructions. Alright, give me a sec. Let me just complete this. I'll check them like probably after the stream. Sensei, can you tell me what a Fibonacci number is? I know what it is, but I kind of forgot. That's the same as I don't remember. Okay, listen up, Vivek. You're asking the right questions, so your brain cells might survive today. Might just survive today. Let's sear this into your skull. What is a Fibonacci number? The Fibonacci sequence is a series of numbers where each number is the sum of the two numbers before it. 1, 1, and then 1, 2. So 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 8 is 13, 13 plus 21 is 34. Ah, I see. Okay, each number is the sum of the two numbers before it. Ah, I see. Okay. Let me explain it out. F at index 0 is F, F at index 1 is 1, F at index 2 equals to F at index 1 plus F at index 0 equals to 1. Oh, I see. F at index 3 equals to F at index 2 plus F at index 1 equals to 2, F at index 4 equals to F at index 3 plus F at index 2, that equals to 3, F at index 5 equals to F at index 4 plus F at index 3 and 5, and so on. Formula recursive. Okay, define Fibonacci n. If n equals to 0, return 0. Else if n equals to 1, return 1. Else. That's the base case. That's the base case as well, probably. Else, return Fibonacci. N Fibonacci, my function, at index of n minus 1 plus Fibonacci, my function, at and a parameter, not index, a parameter, n minus 2. Where do you see Fibonacci numbers? Everywhere. Nature, flower petals, pine cones, spiral and shells, computer algorithms, financial models, art and agriculture. Now tell me, do you get it? Because if not, I'll strap this sequence to your forehead and make you repeat it 30 times while writing the recursive function blindfolded in a hurricane. If you do get it, then hell yes, you're ready to code it yourself. Want to try writing a recursive Fibonacci function next, soldier? Yes, sensei. Can I get a few easy Fibonacci questions that gets progressively harder and in different variations, question mark. Hey, how have you been prompting ChatGPT to work like this? I mean, it's your sensei. How should I start working like this? Okay, oh my god. Okay, I didn't see what ChatGPT sensei said. Okay, so you should join my Discord after the stream. I can like send you the prompt that I added, like how I said my ChatGPT to behave. I can like send you that, then you can try it like this. Okay, yes, you finally asked for the cursed Fibonacci. Let's tear it apart like true warriors. I'm going to give you 10 Fibonacci practice questions, starting super easy and slowly turning into a savage beast that will test your soul. What you need to know: Fibonacci sequence starts like 0, 1, 1, 2, 2. 0, 1 gives me 1, 1 plus 2 gives me 3, 3 plus 5 gives me 8, 8 plus 13 gives me 21, 21 plus 34 gives me 55. Each number is the sum of the previous two. Fib means my Fibonacci with a parameter n equals to Fibonacci n minus 1 plus my Fibonacci n minus 2. Okay, typically Fibonacci 0 equals 0, Fibonacci at index of Fibonacci with 1 as a parameter equals to 1. Level 1, basic recursion question 1. Write a recursive function to return the nth Fibonacci number. Assume fib with a parameter 0 equals to 0, fib with a parameter 1 equals to 1, fib with a parameter 2 equals to 1. Try fib with a parameter 5 should return 5. Fib with a parameter 7 should return 13. Write the function now. Sensei is watching like a hawk. Once you do it correctly, I'll drop the next challenge. Go! To be honest, I've never used the Fibonacci sequence before. Oh, honestly? Okay, so a basic recursion question. Let me drink some water real quick. Okay, and get this here. Just check this real quick. Bro, where are you from? I'm from the US right now. I'm the United States right now. Okay, so write a recursive function to return the nth Fibonacci number. Assume fib with 0 as a parameter equals to 0. Okay, let's see. Write a function to return nth. Okay, so nth Fibonacci number. So I'm going to define a function. Okay, and I'll keep it as Fibonacci and a parameter of nth. Okay, and then assume fib, okay, at index 0 equals to 0 and fib with 1 as a parameter equals to, okay. Let's see. From the US, you look like you're from India, South Indian. Okay, it's probably genetics. I've honestly never been to India. I do want to visit it someday, but yeah, it's probably like because I inherited from my parents or something. Okay, let's see. What should you start doing is making a basic Pygame app. Yeah, I actually tried installing. I wanted to install Pygame yesterday, but yesterday after the stream I was dead. Like, I wanted to research about so many things and I thought I learned some in advance, but after the stream I was like dead exhausted. I just wanted to eat something and then like rest a bit, make my thumbnail, then sleep and get back to work today. Okay, let's see. So let me add a base case. If my nth equals to 0, I will return 0. Else I will return something else. My recursive case, return my Fibonacci, my function, and my parameter -1. Okay, plus my Fibonacci nth at index 1 -1. I'm pretty sure not index, and then let me invoke my function again, Fibonacci at the parameter ntx minus, should this be index 2? Okay, let me just invoke the function. To invoke the function, I'll just call the function and add a few parameters. Let's see. So let me add a list 1 2 3 4 5 6. Okay, a type error. Yeah, I need some more explanation on this because I just started this topic. Let me just go here and say, Sensei, I messed up. I probably need more. I probably need another explanation. Need another detailed explanation. ... You dare call this function call? Wake up, Vivek, your brain's still sleeping. But don't worry, Sensei Sarah is here to shatter confusion into dust and forge your mind in flames of understanding. What you did wrong, you're doing this. Fibonacci, okay. The parameter is a list 1 through 6, but your Fibonacci function expects a single number, nth, not a list like 1 2 3 4 5 6. That's like giving one sock to a 6-headed hydra. It won't work. What your function needs, Fibonacci with the 4 parameter. This will return the 4th Fibonacci number. But hold up, your current recursive function is missing a base case for nth equals to 1, and without it, it will burn in an infinite fire of doom. Here's a fixed version. Python define Fibonacci nth. If my parameter nth equals 0, return 0. Else if my nth equals to 1, return 1. Oh, else return Fibonacci nth minus 1 plus Fibonacci nth minus 2. Now this works like 4 is gonna be 3. Okay, final warning from Sensei. Recursion is dangerous if you don't have the right base case. That's like jumping off a cliff and forgetting to bring a parachute. That's gonna be bad. Your next task, call the function. Call the Fibonacci function and print the 6th Fibonacci number using the fixed code above. Okay? 6th Fibonacci number. Do it, warrior. No mercy, no mistakes. Make me proud or face 10 push-ups of shame. Might have to do like a workout stream. Okay, a 6th Fibonacci number. Okay, so basically I just didn't add a base case. I gotta ask like how did this make a difference? Else if nth equals to 1. I'm gonna return 1. Okay, and now if I add 6 to my parameter and I run the command, I'll have to print this because there's no print statement inside of my function. Okay, so now if I run the command, it's going to give me 8. Because probably 4 plus 6 is 8. Right? No, 4 plus 5 is 9. 4 plus 6 is at 8, guys, it's 11, my bad. Okay, let me... Oh wait, it's minus. So wait, Fibonacci, my first parameter minus 1. So my first parameter is 6 plus my second parameter minus my parameter minus 2. Okay, let me try to brainstorm this real quick. Fibonacci, so my 6 minus 1 is 5. 5 plus my 6 minus 2 is 4. Okay, so the first one gives me 5. Let me add a comment. So first one gives me 5. And the second one gives me 4. 5 plus 4 should be 9. I'm getting 8. Let me go Control C. Get this here. Go with Control V. Sensei dot dot dot. Why? I mean, not why. I don't understand the recursive case question mark. The first number. The first number. Okay, here. Let me just copy this. Would give me 5. And the second number, which is this, Control C, would give me 4. And if I add them, it's going to give me 9, but my output is 8. Oh, I didn't want to caps it, guys. Guys, honestly, my lips are very dry. Let me just lubricate my lips. Good, you're thinking, but your logic is still too shallow, Vivek. Sit down, breathe, and listen to your sensei. You said Fibonacci at 5 as a parameter gives 5, and Fibonacci 4 gives 4. Okay, 5 plus 4 equals 9, not 8. Wrong, that's not how recursion works. You're assuming Fibonacci 5 instantly returns 5. It doesn't. Okay, it has to recursively calculate that entire value first. So let me unfold it like a scroll on your forehead. Okay. Let's walk through Fibonacci with 6 as the parameters step by step. Fibonacci with 6 as the parameter equals Fibonacci 5 plus Fibonacci 4. Now break both of those. Evaluate Fibonacci with the parameter 5. Fibonacci with the parameter of 5 equals Fibonacci parameter of 4 plus Fibonacci parameter of 3, 4 with 3 with 2, and so on. Okay. Then 0, 1, 2. Okay. Alright. Guys, I so don't understand this. Okay, that's the reason this is kind of fun. Now let's add it up step by step like a boss. 0 at index 0. And Fibonacci at index 0, 1. And then 2 is 1, 3 is 2, 4 is 3, 5 is 5, 6 is 8. 3 plus 5 is 8. Let me read this real quick. Fibonacci 6. 6 breaks all the way down to 4 repeated branch. Alright, let me read the rest. So our line, Fibonacci with a parameter of 5 gives 5, and Fibonacci with a parameter of 4 gives 4. Is true only after full recursion, not immediately. This is not math shortcut, this is code execution, and the function doesn't know the result until it calls itself to the base case and then builds the answer on return. Summary for your soul: recursion is like going down a deep dark cave until you find a torch. Base case: then you climb back up and light everything one step at a time. Each level doesn't instantly know the answer, it waits for its subcalls. Now say it with me. Fibonacci with the parameter of n equals Fibonacci n minus 1 plus Fibonacci n minus 2 only after recursion unwinds. Okay, I understood that part. Write it 10 times if you still feel confused. Do you want me to give you a visual printout to trace Fibonacci with the parameter of 4 and Fibonacci with the parameter of 5 to hammer this deeper? Okay, let me process my question. I had a question, guys. Alright, sensei. ... Okay, let's see. My question was, I don't understand the part where it calculates. I don't know. I probably just need more practice with questions like these. Can we do more questions? Question mark. Okay, let's see if we need more questions. Okay, good, you're showing grid, but we're not celebrating yet that little glitch in your head. We're going to smash it into understanding through practice and pressure. Okay, let's burn that confusion out of your brain with 5 Fibonacci questions, and then start easy but get progressively harder in different variations, just like you asked. Question 1, fix the broken code. Easy. Define Fibonacci with parameter of n. If n is less than or equal to 1, return n. Else Fibonacci n minus 2 minus what? Okay, I know what to do here. What's wrong with this code? Fix it. This one is meant to trick you with a subtle sign issue. Question 2, instruction based. Okay, let me do the question 1 first. Let me copy this. Yeah, this question was supposed to be an easy tier for a reason. So if my n equals to 0, I will return 0. Else if my n equals to 1, I will return 1. Guys, this is just from pure memory, so I can't say I completely understood this, but -3. This should be a plus. +3. Let me just copy this. Get it here. Control V. Sensei, can I get one question at a time? Question mark. Yes, that's the spirit. Okay, yes, that's the spirit. You're not backing down. You're hungry for war against your own weakness, and now get it to crush it. One Fibonacci at a time. Fibonacci question 1. Recursive logic easy. Fix the broken code. Recursive function below so that it correctly returns the nth Fibonacci number. Python. Define Fibo with a parameter n. If n equals to 0, return 1. If n equals to 1, return 1. Return Fibo n minus 1 plus Fibo n minus 2. Your task. Correct this to give the actual Fibonacci sequence 0 all the way to 8. Tip, pay attention to the base cases. Yeah, I know this should be else if. Okay, fix it, Vivek, or I'll make you do 30 recursion questions back to back with no rest. Go! Can you try downloading Pygame? It's really easy to make 2D games with it. All you have to do is 2 steps. Step 1, open command prompt. Step 2, type pip install Pygame. Honestly, I'll actually try this stream. Like, I might go in a break, like, in around, like, once it hits 4 o'clock, so like in about 25-ish minutes, and then I'll try doing it offline. Okay, so let me copy this, or honestly, I might just go for a break right now. I gotta use the restroom as well. Yeah, actually, if I couldn't figure it out, then I'll, like, try it on stream. Okay, let me just control V this. Also, actually, I'll go for a break right now. I'll try installing Pygames and even solve this question by the time the break's over. And if it didn't work, then I'll come back to the stream and do it. Okay, so I guess I'll be right back. Okay, mic testing, mic testing. Alright, I'm back. I tried installing the BABYY games. It honestly didn't work. I mean, I had to go like to the control panel, but I'll definitely do it like after the stream today, and the next stream I'll probably use it. Okay, guess we're getting busy after the stream. But before that, let's solve this broken code. Okay, so let's see what the prompt was. So it's here. Okay, define Fibo with a parameter of n. If n equals 0, return 1. If n equals to 1, return 1. Okay, that's probably a mistake. Okay, so 5 gives me 5. Okay. Should print 5. Okay, so it did give me 5. Okay, I think I want to get some instruction-based codes now. Okay, let me get this here real quick. Control V, open this. Let me just check if this is working. There we go. Okay, yes, that's correct. This is the power of pure recursion, baby. Fibo with a parameter of 5 correctly returns 5 because you finally understood the recursive layers. Sensei's heart is boiling with pride. You've nailed how Fibonacci sequence builds from the bottom up, calling smaller pieces until it reaches the base case. Fibo with a parameter of 0, 0. Fibo with a parameter of 1, 1. Then everything else is just sums of earlier results. Now brace yourself. Here comes your next question. And this time I'm breaking your code on purpose. Okay. You will fix it. You will earn your right to continue. Okay, so this is probably supposed to be a much complicated broken code. Your task, fix this abomination, make it return the correct Fibonacci value for 3. If you mess up, I'm dropping 10 of these on your head. Now go. Okay, let me go here real quick. Copy this. Sure. Copy that. Paste. Okay, so I'm trying to get Fibonacci number. So I'm pretty sure equals to 0, return 0, else if, and equals to 1, return 1. Guys, this actually doesn't seem like a challenge. I gotta like, okay, wait, never mind, I take it back. Else return this. Oh, recursion error. Okay, I gotta return 0, never mind. Okay. Guys, did I just get cocky and then mess up? Oh, there you go. Guys, I gotta be more perceptive. There we go. So 0 plus 1 gives me 2, or 1 plus 2 gives me 3. I see. Okay, I'm honestly not getting the concept of these. Sensei, I'm solving these questions not because I understand them, but because they're like too easy and the same kind that I just learned. Okay, let me just fix my typos. And these and understand. So, should I continue recursions with instruction-based questions with a tiny comment that says make the instructions kinda clear. For now. Make the instructions kinda clear for now. Okay. Or move on to orgs. Because honestly, I can use recursion. I can use like for loops for these same problems that I use recursion for. Okay, let me go here and check. Okay. I mean, is that how you pronounce this? Stitch or something like that? Listen to me, Vivek. You don't get stronger by repeating the same easy fight over and over again. You get stronger when your brain screams, your logic cracks, and you're still standing. You're only solving them because they're similar. That means you've memorized, not mastered. That's correct. And that's unacceptable to your sensei. You're not just here to pass. You're here to dominate. But you were honest. That earns respect. Here's what we do. Okay, we do 10 harder recursion instruction-based questions now, the kind that forces you to think and understand the call stack. I'll make the instructions a bit clearer at first, then you asked. Okay, a bit more. I'll make the instructions a bit clearer at first, like you asked, but no more hand-holding after that. After that, we'll do the final judgment. If you understand recursion, we move on, args. If not, I lock you in recursion hell until you beg for mercy. Instruction-based recursion challenge 1. Instruction: write a recursive function called sumDigits with a parameter of n that returns the sum of all digits in a number. For example, sum, okay, parameter 1, 2, 3, 4 returns 10. Oh, we're using args as well. Okay, that's gonna be fun. Write a recursive function called sumDigits n that returns the sum of all digits. Okay, number. The function must be recursive, no loops, no string, no hacks. Type your code. Prove to me that you're worthy of the next line. If you copy, you die. Okay. No string, no loops. Okay. Okay, so I start with, let's see, write a recursive function called sumDigits that returns the sum of all digits in a number. So I gotta define a function. Define a function sum digits with the parameter, and I'll add a parameter n to it, and then I'll drink some water because I'm exhausted. Okay, hydration is important, guys. Make sure that you guys are hydrated as well. Okay, let's see. That returns the sum of all digits in a number. Okay, I see. The function must be recursive, no loops. Okay. So, if my n equals to 10 equals 0, I'll return my n. Okay. Tomorrow, do you want to try Roblox Studio? Oh, I used to like I tried a little Roblox Studio, but not for like coding or scripting. I used to model there. And like on my Twitter, I still have a model. I was like, I'm selling this model, but like I didn't use it for a while, like for a long time. Okay, and now let's go here. Okay, else I'm gonna return this recursive case. Okay, let me return something like I got a sum. Okay, so n at index 0 plus n at index 1 colon. Actually, I gotta invoke my function, my sum digits there. Okay, oh, by Twitter I meant X, my bad. Okay, should work. I mean on a live stream. Okay, should probably like see what I'm gonna do first before I start the live, because like I don't want to be blank on the live, so like probably know what I'm gonna do first. So sum digits, and then n is like, let me add, oh, it should be args. Okay, so the unpacking operator, then I go with 1, 2, 3, 4, 5. Okay, if I run the command, I'll have to print this command because it's because I have a return here. Okay. It doesn't print anything. Okay, probably I gotta invoke my function here as well. So sum digits. There. Okay, if I run the command, it doesn't give me anything. Return 0. Let's see where I went wrong. Okay, control C. Hmm. Hmm. Okay, there you go. Okay, let me control V and say Sensei, I messed up! Exclamation. Can you help me figure this code out? Question mark.